All right, I'm Ryan Bear.
And I'm Sean Forsberg.
Okay, we're Team Hang Loose. That's our logo right there. We built a PS2 to keyboard LCD driver. Basically, what we wanted to do is implement a fully functional keyboard that received its input from the PS2 keyboard and output to the LCD. And we wanted it to display all 26 letters in lowercase and uppercase, all 10 numbers. We said it should have a backspace. It should have a cursor that's manipulated with the arrow keys. It should roll over the width of the LCD, not the width of the memory. And then also have multiple lines of characters, so we could scroll up, scroll down. Also enter would drop us down a line, and escape would clear the screen. This is our block diagram. It's fairly basic. We have our microblaze processor, and there's no PB button. It feeds our GPIOs. That included one button. The PS2 is actually shown here. It's supposed to go into the microblaze via the UART. I messed up talking this thing, and I'm not safe. Also, here's our LCD. That's the GPIO.
So for the overview on it, of course you have all the regular components in there, and we have the PS2 keyboard, you have the LCD display, so that part of it was pretty simple. Hardware, getting the integration wasn't too bad. Of course all the keyboards have different frequencies, so that made a little more interest, and you can't get a lot of it that just sat in. A lot of the complexity happened with the coding itself, because when you're doing like word processing type of functions, which is basically what we outlined in the beginning there, there's all kinds of special cases that come up, like how do you up arrow through things, you have to have buffers for it, having enter, create a new line and start over and not continue writing, all those little edge cases that came up were kind of a pain. So for the integration and testing, getting the keyboard to work was one of the first things on there. Of course, we already had the LCD going from previous labs and had a very reliable driver for that. Of course, frying a board is always a good way of doing your project as well. So fried one of the transistors on board the PS2. Everything else on the board works great though. Once we got the frequency going, then the next thing that we ended up doing is just having it display the hexadecimal codes that were being passed from the scan codes themselves and displaying them on the screen. And then after that, it was just creating an interface to take a scan code and do all those various functions on it. So that just took a little bit of time there. The kind of cool thing that we didn't, or that is not the main functions, but works with our testing here, there is a function on our keyboard as well. You hit F1 and you hit a key and it'll show you what that scan code is. And when you lift up, it'll show you it'll show the full scan code, not just that one entry. So it'll show the up character and then the scan code number itself. Or if you hit one of the special keys like the gray keys that have the enable function, it'll show that full scan code. Made it useful for debugging and to make sure the keys were actually what they said they were on the spec sheets. So that was kind of helpful. But we can actually go over and show you our project back here. So it's pretty simple. It's just like any old word processor that you can type in stuff however you want it to. You also can backspace. You can type stuff, arrow over, and the cursor, of course, is flashing, showing you where you are, and you can delete items. You can add a new line if you wanted to and type in there, but all the data is, and that's being a little odd, but it's getting upset with something on that new line character. The carriage return was the most difficult part of this project because it's a very, very special case to say go over to a new line, and also when you're wanting to do up arrows and down arrows and stuff like that, finding where you are is not a super simple task. But so you can have the items here where you're actually typing in the various things, as I mentioned, up and down through the buffer as much as you wanted to type in here. It should just continue to scroll on through it. Actually, I think I had the buffer. I didn't reprogram it with the larger buffer. So I can do that real fast. That's why it's looping on us. So type in here. Now you're on the second line. It'll roll over to a third line, and it's keeping all the history there. So kind of cool there. As I mentioned on the scan codes, you hit F1 and you can actually see exactly what the scan codes are. So what was the full scan code that was sent last? For gray ones, you get the down as having the enable, and when you lift it up, you see the full command there. That was also helpful because features such as shift actually fully function. So when you lift up off the shift, it stops doing caps locking, and when you push down on it, of course, it does the capitals itself. Caps lock also works on there. Other features that are here is you also do have replacement mode, so you can have it overwrite. You can do it like normal mode where it's adding characters in there. Home works, so you can go back to the beginning of a line and add into that. End works, so you can go back into that. Page up and page down also works, so you can page up and down. It'll do a screen worth at a time. What other functions did I throw in there? Arrow keys. And all the keys are also mapped, which is kind of handy. So if you wanted to add more functions, it's just a big case statement that you can put in extra functions in there. For the actual keys themselves, though, a handy way of doing that as well is it's just an array of what the actual key values are. That'll be displayed on the screen. So if you don't have a special case of what to do with that key, it just displays based on an array of all the scan codes. It was an easy way of kicking it in real fast. And then, of course, you do also have your shift functions for the numbers. So you have full shifting capabilities and all that. Oh, and if you hit caps lock and do numbers, it actually does numbers because you don't caps numbers. So it actually keeps that logic separated. But it was all these little details. When I originally chose this project, it was like, all right, let's do something fairly simple. We can kick it out pretty quickly and won't get special cool credits, but it was way more difficult than I thought because of all those little nuances. So there you go.